Hello everyone, how are you? I had presented other video tutorial before this discussion. Here today I present to you when do we take task slice during real-time scheduling, especially cyclic scheduling. When do we take task slice? In the last discussion, we have seen or explained that there is a cyclic scheduling that's calculated with two different things. The one is hyperparameter and the other is frame size. And to determine the frame size, we had three criteria, and we discussed this each. For example, if we had given tasks are here and we have parameters based on the calculated spreads, we have to find the hyperparameter. Then by the three criteria we have to calculate the frame size, and after obtaining this frame size we create the schedule table. The question here today's discussion is, when do we take task slice? That is, we take task slice and reason if there is no frame size exists depending on its constraint or its criteria. If we can't get frame size, we need or we subjected to take task slicing. So if frame size constraint cannot be met, what to be done is taking task slicing. For example, take example 1. This is by two reasons. In two cases we take task slicing. In the first case, take this example. That means if a frame size is not exist depending on the constraint, what we do, for example, take t1 is equals to 1 and 4, t2 is equals to 2.7 and 5, t3 is equals to 5 and 20. And by the constraint, by first constraint, the frame size should be greater than the largest computational time. That the largest computational time here you see is 5. So constraint 1, frame size should be greater than or equals to 5. By constraint 2, frame size should divide f evenly, or should divide f not f h, or hyperparameter evenly. Hyperparameter means the LCM of h periods, 4, 5, 20. So the LCM of 4, 5, 20 is 20. So the factor of 20 is 1, 2, 4, 5, 10 and 20. So we'll take that each one by the constraint 1, 2 and 4 is not working, since this greater than to be greater than 4, 5, because greater than 2 computational largest computational time. And the next constraint, there should be exact line that meet through this formula, which means 2 times f minus GCD of f and ti less than square di. Ti and di are the same thing. The smallest period, smallest still line is the same thing. So we take here the smallest period is 4. So it should be the selected grid or the selected frame size should be less than or equals to 4. So you see here, f should be less than or equals to 4 according to constraint 3. f should be greater than 5 according to constraint 1. So this makes not overlapping. It should be give overlap. No value that is greater than 5, that is less than 4. There is no value. So in this case, we are subjected to take task slicing. So what slicing mean? Slicing mean dividing the larger computational time of a given task into 2 or more different parts that to be executed in given period only. So here is the largest computational time of the task is 5 and 20. So this 5 to be into 2 or more parts here divided as 1 unit, as 3 unit and as 1 unit, each computed in a given 10 unit only. So in this case we get the larger or let the largest completion time to be 3. So f can be greater than or equal to 3, and thus we take the factor of 20 testing for its work. We select frame 4 and can create the schedule table. This is condition 1, which means frame size does not exist. Condition 2. Frame size is obtained but do not fit for tasks to be completed in a given frame. That means we are discussing in previous video or so, there should be complete frame between the release and deadline of every task. Based on this formula, there should be complete frame between the release and deadline of every task. So that's we got the frame, maybe assume we got the frame size, but that frame size is not fit for the given task. What we do again, the next chance or other second chance or other second application, we are subject to take task slicing. For example, take this as example 2, and let your task is given here. T1 is 2 and 5 for free, 2 for completion and time. T2 is equals 2 and 10, the same 4 and 5 for 3. So first we determine the h, which is the factor of 5, 10 and 15 is 30, and we find f depending on the criteria. Before we go to the entire work, we have to determine the smallest period or deadline, which is 5, is according to the given. So the frame size optional can be the factor of 30, which is 1, 2, 3, 5, 6, 10, 15 and 30. But in the second constraint, the frame size we select should be greater than the largest completion time. This largest one is 4, 2, 2, 4. So the options we select 1, 2 and 3 isn't working, does not make overlap. So we select our frame size starting from 5 in case of constraint 3. So for this formula, first we take 5, then 2 times 5 is 10. The greatest common divisor of 5 and 5 is 5 itself, because we smallest deadline we select is 5. The common divisor of 5 and 5 is 5. 10 minus 5 is less than or equal to 5, which is true. Let's take other chance with 6. 2 times 6 is 12. 12 minus the greatest common divisor of 6 and 5 is 1 only. So 12 minus 1 is 11, which is less than 5, which is false. Again, if we take 10 or so, 2 times 10 is 20. The greatest common divisor of 10 and 5 is 5. As 20 minus 5 is 15. 15 is no less than 5, and this other makes false. So the true only the frame size we select is 5 here. Yes, we select frame size now. Frame size obtained. Is it fit for the tasks? You must know that T1 repeat at each 5 units, which is 2 unit, 2 unit, 2 unit in each frame size. But the frame size is only 5. But T3 need 4 units at any part of the frame and any thread. But there is no frame size that can get expanding 2 units for T1 and remaining out of 5 units is only 3 units. So how can we serve this? We can serve T2, no problem. 2 units for T1, 2 units for T2, and the remaining 1 unit we left as free space. But how can we serve T3? Since 2 plus 4 is 6, but the frame size we're selecting is only 5, and the rule says that there should be a complete frame between the release and deadline. Means there should not be overlapping of the task cannot start from first frame and cannot jump to the other frame. It should complete only in the execution in the given start frame only. So in this case, we had got no frame size, but we are subject to take task slicing. Therefore, we get 5 square, but the frame size do not fit for with the tasks. So we need task slicing. So what can do is for the larger completion time of task 3, we can divide into 2 or more parts. Here I divide to T3 1, 2 and 15, T3 2, to other 2 and 15. Those 2 units should be computed only in given 50 units only. So that can be computed correctly. And now the larger functional time work frame constraint be 2. That's 2 can be work checking, 2 work 0, 3 might not work with 5 and 3 only 1, 2 times 3 is 6, 6 minus 1 5. Yeah, 3 also works, but 5 also works. That's 3 2 they are less than 5, 6 isn't working. So the larger selection, the what chance it will be the 5 is work correctly. That is 5 occurrence is constant, so that we can serve now these functions. For example, how can I serving is let 2 unit for let first, right? This is let for this one is 1, this is 5, this is 10, this is 10, this is 15, this is means h per 8, h5 unit, this is 20, this is 25, sorry for the visual writing, this is assume that 30, that is the measure cycle completed, and it repeats itself again in this way. That is cyclic, we say that. Cyclic, we say that. Then for first 2 units, assume that is 2 units. This is for T1. Next 2 units that might be given for T3, no T2. The remaining is 1 unit. So this is 2, or this is 4. Remaining 1 unit. Assume that it's only. Or let clear, that's clear to be clear. Assume that there's 2 units for T1, there's other 2 units for T2. This remaining is left as this remaining is left. Next, T2 again start at the same thing. There should be 2 units for T2. T2 you see, no T1, not T2, and the T2 repeat after 10 units. T2 repeat after 10 units. So here can use for our slice time. For slice time T31 or T2, no problem. Wherever it is, it can start in any position. So let I use 2 units here for 3 or 1, and the 1 unit again remains for empty. Oh, 10 complete now. T1 starts always start at H5 units. T1 starts at H5 unit. Let's get 2 units for T1. Remaining T unit can give for T2. Can give T2. This is assume it's 1 unit only. This remain left. Again, here is 2 units clear for T1. That's mandatory. First T1 starts at H unit. Again, remaining 2 units let's give for before 20. T2 cannot repeat. So this position can be used for T3 2. The remaining part of no, this problem because T3 have to compute each in within 15 time units, within 55 time units. So this to be for T3 2. This is for T2 can be used because before 20 it can only 1 unit, that can be. So here T3 2 should be computed here only, unless this problem before 15 2 units to be computed, means 4 units to be computed within 5 units of time there. But starting given for it complete that frame only. That means part into 2 different parts. One is completed on this, here other completed on this part. So T2 only comes here. I'll make it somewhat clear. T2 be within before 20. Yes, correct. This is remaining left. Next, in this part again 2 units for T1. This is for T1. Okay, now T2 had here. Okay, no, T2 before 10, yes, before 10 here 1 unit, yeah, correct. Before 22, T2 here again, that's correct. Let I color, this is for T2. Let I color this for, no, that's not good color, for T1. This is also again for T1. Again this is for T1. In each 5 units T1 is restarts. Again T1 restarts here. This is T1. T2 selected this color. Here is T2. T2 where is T2 again? Before 10, here is after 10 and before 20, here it is after 20 and before 30, it can be here T2 only there, and remaining let us say T4, T3, not T4, this is T3, one part, T3, other part, within 15 units. Within before 30 there should be again T3, 2 units completed to be. So where that take place, where can this can take place? Is there any place T2 on T2 there? There is within 50 it's executed. T2 again come here. No, before 20, before 30, T2 cannot come here. Before 20, before 10, T2 before 20, it's come here. No problem. 10 units, T2 can be here. And there is remaining 1 unit. There is T2 can take the remaining 2 units, remain to it. Anyhow, if there is problem again, we taking slicing again into different components. That means if 2 is not working, we take slicing again into 1 1 2. That is also essential thing to be to that different components. So that can be again since it's a problem, you have seen that say 31 can be in the bracket 1, 15. 1, 15 T over 3 2 is equals to and comma 1, 15, and next T33 is equals to 2, 15. This can be this. So this isn't working as you have seen. This is not working, you have seen. So the other new this option, this 2, this 3, this option is best. You have to take this option, and then you have 3 different components. 1 unit sum here, 2 unit sum here. It's gonna work. So now the sum slicing can be subjected in 2 cases. 1 if the frame size does not exist, 2 frame size obtained but that is not fit for the given frame. That's why we are subject to take time slicing. Thank you very much.